So that's why I written as integral of double integral of S1 plus S2 plus S3 plus S4 plus S5. S6 we are not going to consider because this is XOY plane. So first we will go for S1. S1 is nothing but A, B, G, F. So you have A, B, G, F. So this is facing you, okay, towards you. We are going to consider this plane. Very simple one. We are going to consider this plane. This is facing you. So this is A, B, G, F. Okay. Whatever the projection, this will be your I vector. So you have del cross F dot n dot ds. Del cross F already we have found out. Just now we have found out del cross F. So we have del cross F is given by this, and your n ds dot n ds is nothing but, see here, this is facing towards you. So this is in the coordinate x. So it must be I. If it is in reverse, it must be minus I, which we have already studied earlier in the last session. We studied. So if it is, this is I, and this must be your minus I. If it is j this side, this must be minus j. If it is k this side, this must be opposite direction, must be minus k, which we have already studied earlier. So we have minus I dy dz. Dy dz is a plane. We have to remove. We should not include dx. Is it okay? Your ds is dy dz. It's a surface area. ds is dy dz. And your n cap is nothing but your I vector. So now I with I, other things and all will become 0. So you have I with I. I with I will give you minus y dy dz. Is it okay? Other terms and all will become 0. So you have I with I. So minus y dy dz. So the limits will be 0 to 1, 0 to 1, because it's a cube. X goes from 0 to 1 for x direction. For y direction also 0 to 1. For z direction also 0 to 1. Now let us solve, let us integrate. So we have y dy, integrating, that will give you minus y squared by 2. Substitute the upper limit, that will give you 1. So minus 1 by 2. Substitute the lower limit, that will give you 0. So here 1 by 2 is z. So minus 1 by 2 is z. So 1 by 2 dz. 1 by 2 dz. When you are going to integrate, that will give you z. So minus 1 by 2 is z. Substitute the upper limit, that will give you minus 1 by 2 minus 1 by 2. Okay. So this is for the value of S1 integral. Okay. For the right hand side. So similarly you have to go for the S2. So del cross F dot n ds. So your del cross F is given by this. As I said, you are going to consider OCDE. OCDE. So this is inside. So earlier we calculated facing towards you, this side. Okay. Now we are going to calculate this. So this must be in the minus I direction. See, minus I direction. And your ds will be dy dz. You have to exclude dx. Okay. So that will give you minus plus. So y dy ds. And of course, when I am going to integrate y, so that will give y squared by 2. Substitute in the upper limit, that will give you 1 by 2. 1 by 2. So dz. 1 by 2. Then ez. You will have to substitute the upper limit, that will give you 1 by 2. So your S2, the answer for the S2 will be 1 by 2. So now we will go for S3. S3 is the side BC DG. BC DG. So your BC DG. See this side. So this facing this side. Facing this side. You have B, C, D, G. So this is towards y direction. So it must be J. And next time you are going to consider this direction. So it must be minus J. Is it okay? So you have ds will be dx dz. It will not include dy. Okay, we'll see. So we have now S3. As I said, this will not include dy. Okay, so you have plus j direction. So del cross F is given by this, and j dot j will be 1. Other things now will become 0. So j dot j will give you 1. That will give you z minus 1. So separately you can integrate. So when you are going to integrate separately, that will give you z dx 0 to 1 dx dz. So that will give you z. We are going to integrate. So that will give you x. Substitute the upper limit, that will give you z alone. And this side we have x, substitute the upper limit will be 1. So now we have now this integral. Okay. Now when I want to integrate this z ds minus dz. Z ds minus dz. Z ds will give you z squared by 2. So substitute the upper limit, that will give you 1 by 2. Here it is z, substitute the upper limit, that will give you 1. So we have 1 by 2 minus 0, substitute the lower limit, and here it is minus 1 minus 0. Okay. So 1 by 2 minus 1. 1 by 2 minus 1 will be minus 1 by 2. So we have found out now S3. Now we will go for S4. As I said, S4 will be minus j, opposite direction. So we have del cross F dot minus j dx dz. Your del cross F is given by this. So we have minus sign here, j minus 1 j vector with minus j vector will give you this. Separately you can integrate. So when you are going to integrate, that will give you z x with the limit 0 to 1, and here it is x 0 to 1 dz, and again you can separately you can write z minus 1 dz. So this can be integrated with respect to dz, that will give you z squared by 2, and this is minus z. Substitute the upper limit, that will give you 1 by 2 minus 0. Substitute for z upper limit, that will give you minus 1. So 1 by 2 minus 1, so that will give you minus 1 by 2. Is it, there's a mistake or what? We'll see. Minus 1 by 2. It must be plus 1 by 2. So we have 1 by 2 minus 1. We'll see. So now del cross F dot n does. So now it is a top surface. Top surface will give you k. And of course we have a bottom surface which is excluded. Correct? XY plane is excluded. So we are going to have only this alone. This is your last one. Last surface. S pi. So we have k dot k. Answer will be minus 1 dx dy. See, look at ds, it is dx dy. We will have to exclude dz. So minus 1 dx dy. So integrating, that will give you x 0 to 1 will give you, substituting the upper limit, that will give you 1. So dy is here. Again when you are going to integrate, that will give you answer is y. Substitute the upper limit, that will give you minus 1. So now we will have to substitute. This is for S1, this is for S2, and this is for S3, and this is for S4, and this is for S5. So now there's a mistake here. As I said, 1 by 2 minus 1 will give you minus 1 by 2. Minus minus plus. So this must be plus. So plus 1 by 2. Okay. So there's a mistake here. It is plus 1 by 2. Now this is minus 1 by 2, plus 1 by 2, minus 1 by 2. The last one is plus 1 by 2. Plus 1 by 2. See, plus 1 by 2. And the last one is minus 1. So we have minus 1 by 2 will get cancelled. Plus 1 by 2 minus 1 by 2 will give you, this one will get cancelled. This one also will get cancelled. Answer is minus 1. So we have right hand side is minus 1. Correct? So we have found out now 1. Right hand side alone. We have found out del cross F. The right hand side for the Stokes theorem we have got as minus 1. Okay. Now we will go for the left hand side. Left hand side we need to have f dot dr. So we know f. We know already dr. So f dot dr will give you this. So integral f dot dr will give you, just look at the picture. See, now earlier we calculated for the surface 6 surfaces. So as given in the problem, we will have to exclude one surface. So we have calculated 5 surfaces. Correct? For del cross f. For the right hand side, it is surface. And for the line integral, we are going to go with 0 to a or a to b plus b to c plus c to o. So line integral is this one. Either way you can go. You need not go, see here, 0 to a plus a to b plus b to c plus c to o. So we are going to have all the four integrals. See, we are going to have all the 4 integrals and add. So that will give you total line integral f dot dr. Is it okay? F dot dr will give you, f dot dr is given by this. So f dot dr is given. Now thing is, along, see here we have along OA. This is OA. So this is OA. Now x goes from 0 to 1. Y is 0 here, z also is 0. Look at the limit now. X goes from 0 to 1. Okay. So now along OA, x varies from 0 to 1. What about y? Y is 0. See, there is no variation in y here. There is no variation in z here. X alone is varied from 0 to 1. Okay. Y is 0. Z also 0. So now x varies from 0 to 1. So y is 0. Z is 0. If y equal to 0, dy equal to 0. If z equal to 0, dz equal to 0. You substitute here in the integral. Y equal to 0 will give you 0. We have minus z also 0. So we have 2 dx. 2 dx. Dy is 0. Dz is 0. So integral 2 dx. Okay, what is 2 dx? What is the limit for OA? X goes from 0 to 1. See, look at the picture. It is 0 to 1. Here it is 0, 0, 0. Here it is 1, 0, 0. It implies that x alone varies from 0 to 1. Y is 0. Z is 0. Is it okay? You understand first this very simple one. And it will be very difficult. You understand this first. So 0 to 1. 0 to 0. 0 to 0. Okay. So that's why we written like this. So now, so that will be 2 dx, 0 to 1. Pull 2 out, dx, integrating dx, that will give you x, substitute the upper limit, that will give you 2. So we have found out now this integral, OE. We'll go for now the second one, AB. Second one is AB is here. AB is here. Okay. What about x? X equal to 1 to 1, so x equal to 1. What about your y? 0 to 1. What would you z? 0 to 0. So you have to remember this. So it is AB is given as y alone varies from 0 to 1, x equal to 1, of course, z equal to 0. Correct? See, here it is. This is your AB. Y alone varies from 0 to 1. What about x? 1 to 1. There is no variation. 1 to 1. And 0 to 0, z also. So there is no variation. So we have y alone varies from 0 to 1. Z equal to 0, x equal to 0. If x equal to 0, 1, x equal to 1, dx equal to 0. The dz also will be 0. You substitute here. So instead of x, you have to substitute 1 here. And what of dx? Dx equal to 0. So first term will not appear. And this term also will not appear. And here it is z equal to 0. So we have 4 dy alone. So 4 dy alone. Is it okay? See here, y varies from 0 to 1, x equal to 1, and dx, in a differentiate, so dx equal to 0, z equal to 0 means dz equal to 0. So dx equal to 0, dz equal to 0, this term alone will exist. So we have yz plus 4. And what about your z? Z equal to 0, so this term will not appear. So we have only 4 dy. So 4 dy, integrating will give you 4y, substitute upper limit, that will give you 4. So your next integral AB, the value is 4. Next one will be BC. So your BC is here. So x goes from 1 to 0. So earlier 0 to 1. Now it is 1 to 0. Okay. Upper limit C 0 to 1. Now it is 1 to 0. What about your y? There is no variation. 1 to 1. What about your z? So that also no variation. 0 to 0. So we have now BC. BC, x goes from 1 to 0, y equal to 1, no variation, z equal to 0, that's no variation. So dy equal to 0, dz. So substitute now dy equal to 0, dz 0, this term will not appear. And this term alone will appear, correct? And what of x varies from 1 to 0, y equal to 1. So y equal to 1 means 1, z equal to 0. So 1 minus 0 plus 2. So 2 plus 1 is nothing but 3. So 3 dx. Is it okay? So substituting the upper limit will give you, now see here, upper limit will give you, first you will have to substitute 0. Then lower limit you will have to substitute the next one lower limit, that will give you minus 3. So your third integral answer is, line integral answer is minus 3. The last one is this one. So we have now 0 to 0, 1 to 0, 0 to 0. So we have the last integral, which is nothing but CO. Y varies from 1 to 0, x equal to 0, z equal to 0. So substitute here dx equal to 0. This one will not appear. This one also will not appear. Y z plus 4, z equal to 0. So 4 alone will exist. So 4 dy. Now 4 dy will give you 0 minus 4. So you have to substitute the upper limit first. Then next one is the lower limit, that will give you minus 4. The answer is minus 4. So total line integral will give you 2 plus 4 plus minus 3 minus 4. So you have minus 4 is here, minus 3 is here. Okay, then we have 2 is here, then we have 4. So 2 plus 4 minus 3 minus 4 will give you minus 1. Okay, minus 1. Already we have found that del cross f is nothing but minus 1. So which is equal to right hand side. Which is equal to right hand side. So thus the Stokes theorem is verified. Okay. Now we'll go for the last problem. So last problem. Verify Stokes theorem for f is given by this vector x squared minus y squared j plus 2xyj in the rectangular region. So this is in the rectangular region. In the xy plane bounded by the lines x equal to 0, x equal to 0 to x equal to a, y equal to 0 to y equal to b. So we have two boundaries now. One is 0, 0, another one is a 0. One is 0, 0, another one is 0, b. Is it okay? So we have a rectangular boundary. So if it is so, it is 0, 0, this must be a 0 because x goes from 0 to a. And here it is 0, 0, it must be 0, b because y goes from 0 to b, see 0 to b. What of this other side? That will be a comma b. So this must be a comma b. Okay, so this must be a comma b. So we have a comma b here. Is it okay? Now this line x alone will exist. X alone goes from 0 to a. What about y? Y equal to 0. This y alone will go from 0 to b. So your x equal to 0. You should understand all these things. Now according to Stokes theorem we know this. Now we will go for the left hand side. Left hand side is f dot dr. So f dot dr, that will give you line integral. Okay. So line integral, first we will have to calculate f dot dr. So f dot dr will give you, your f is given by this, dr is given by this. So I with I will give you this. Okay, you have j with j will give you the second term, and there is no k term there. There is no k term there, correct? So we have I term alone, j term alone. See here, I with I, j with j. So we have x squared minus y squared dx plus 2xy dy. So now as I said, line integral that will go from 0 to a to b, b to c, c to o. So o to a, the first one. Second one will be a to b. Third one will be bc. The last one will be c. So first we will go for f dot dr with oa. So f dot dr with oa. So f dot dr is given by this. What of this? This is y equal to 0. If y equal to 0, dy must be equal to 0. So dy will be 0. So if we have dy is 0, y is 0. So you have x square dx, x square dx. Is it okay? Simple one. See here your x goes from 0 to a, y is 0. So that's why we written as y is 0 here. Y is 0, dy equal to 0. So dy equal to 0. So we have x square dx. Integrating that will give you x cube by 3. Substituting the upper limit will be a cube by 3. Now we will go for the next one, AB. So first we have calculated OA. Now we will go for AB. AB is given by this line. Okay, AB is given by this line. So f dot dr is given by this. What about your x? X equal to a. If x equal to a, dx equal to 0. Y goes from 0 to b. Okay, y goes from 0 to b. Is it okay? See, this is, we have calculated OA. Now we are going to calculate AB. So this is AB. AB, x equal to a, y goes from 0 to, see here, 0 to b. A is constant here. So dx equal to 0 will give you, the first term will be eliminated. The second term will be 2xy dy. So 2, instead of x you have to substitute a. So 2ay dy, which is equal to 2a y squared by 2. Substituting the upper limit will give you 2ab squared by 2. This two will cancel. You have ab squared. So you have the second integral. Value is ab squared. Third one is b to c. b to c, y equal to b. So dy equal to 0. Immediately we can say. So y equal to b, dy equal to 0. So your f dot dr in this region. So substituting y equal to b will give you b squared. So x squared minus b squared. dy is equal to 0. That last term will be eliminated. So we have x squared minus b squared dx. Integrating will give you x cubed by 3 minus b squared x. Substituting the upper limit first. So it goes from, see, a to 0. See here, this is a to 0. Okay. So now a to 0, your dx. So substituting the upper limit will give you 0. Lower limit will give you minus a cube by 3 minus b squared a. So that will give you minus a cube by 3 plus ab squared. Now we'll go for the last one. Last one is f dot dr. This is your f dot dr. What about your last one? Last term will be from here to here. Okay. X equal to 0. So dx equal to 0. X equal to 0, that will give you dx is 0. X equal to 0. This term also will become 0. This term also become 0. So answer is 0. So f dot dr is nothing but this term plus this term plus this term. So all the three terms. All the three. Last term becomes 0. So we have all the three terms. Okay. First term, second term, and third term. So this term will cancel. ab squared plus ab squared will give you 2ab squared. So this is the answer for your left hand side. Now you go for the right hand side. Right hand side of the Stokes theorem will give you del cross f dot n dot ds. First we will have to calculate del cross f. So del cross f. F is given by this. So substituting here, that will give you del cross f. So as usual, you have I vector dy by dy 0, d by dz of 2xy minus j d by dx of this term, d by dz of this term, plus k d by dx of this term minus d by dy of this term. So this term, there is, here it is 0. This term, it doesn't contain z, so this become also 0. There is no ith term. See here, this is 0. There is no z term here, so this also will become 0. Now we will go for the last one. When I am going to differentiate with respect to 2x, I will give you 2y. This will become again 2y. 0 minus 2y, already minus is there, so plus 2y. So 2y plus 2y will give you 4y k vector. Now del cross f dot n ds. Your ds already we have seen earlier. N cap ds. This is nothing but dx dy. Your n cap is nothing but k vector. So this is the plane, as we explained already, that this is your k vector, correct? So this is your k vector. So your n cap is nothing but k vector. Del cross f already we found out, this is 4yk, k dot k will be 1. So 4y dx dy. Okay. So your del cross f is nothing but 4y, pull 4 out, so y dx dy. Now limits will be for dx, limits say for x 0 to a, for y it is 0 to b. You keep y as it is. When you are going to integrate, that will give you x. Substitute the upper limit, that will give you, here it is a. You pull a out, so 4a y dy. So now integrate, that will give you y squared by 2. Correct? Y squared by 2. And this 4 and 2 will get cancelled. We have 2a. Here it is b squared, so 2a b squared. So which is this is your right hand side, so which is your left hand side. So left hand side equal to right hand side. So it implies that Stokes theorem is verified. So we have solved some problems, okay, on Stokes theorem. Thank you, students. We will see you in the next class.